Imagine a user sitting down at their terminal, typing a single sentence. Create an audio campaign called Back to School Promo targeting 25 to 44-year-olds in the US with a $100 a day budget. That plain text intent has to navigate an enormous enterprise API architecture to actually execute. The immediate friction lies in the reality of the Spotify Ads API version 3. It contains over 30 separate, deeply nested resource types. To launch that requested promo, the system has to build a strict hierarchy. First, it generates a campaign entity. That campaign must then contain an ad set entity. Finally, that ad set houses the specific ad entity. You cannot build these out of order. Each step requires extracting specific IDs and validating targeting parameters from the level directly above it before the next operation can proceed. For an AI agent trying to process a single English sentence, bridging the distance between the user's initial thought and a sequence of perfectly chained post requests is a complex, multi-step dependency problem. The standard developer approach to solving this is brute force, writing hundreds of lines of brittle, hard-coded orchestration logic to map out every possible execution path. The modern alternative attempts to solve this by dumping the entire API schema into an LLM static tool registry, hoping the model can sort out the connections. Abstracting execution into compiled code or massive black box registries becomes a severe liability when those API calls are directly manipulating real-world advertising budgets. Spotify Engineering proposed a different architectural thesis. They bypassed compiled orchestration entirely to build a system where the LLM routes itself through the hierarchy. This approach explores whether raw documentation can effectively function as the primary source of application logic for the agent. Currently, the Model Context Protocol, or MCP, serves as the industry standard for connecting LLMs to external tools. This diagram compares the standard MCP approach on the left against Spotify's alternative on the right. Defining nested request schemas as static tools creates a massive JSON block that bloats the context window, burdening the LLM with unnecessary schemas. But on the right, you see the file-based alternative. Spotify built a Claude Code plugin entirely out of uncompiled Markdown files. There is no build step and no transpiler. Skills define the slash commands, agents handle natural language, and docs ground the API knowledge. This enables dynamic loading. The agent pulls only the specific reference documentation required for the precise request it is currently processing, on demand. Modular, file-based context loading preserves the model's reasoning capabilities by keeping the context window uncluttered, a stark contrast to loading massive static tool registries. We can trace this logic directly. The moment a user prompt enters the system, it hits a specific Markdown agent named Spotify Ads Request Builder.md. The agent immediately performs native data conversions. If the user asks for a $100 budget, the agent seamlessly converts that string into the precise microunits the API demands. Geographic targeting requires a similar translation. The agent must map a human-readable state name, like Connecticut, into the platform's exact region ID. To achieve this, the agent actively pauses its workflow mid-thought to call the /target/geos endpoint, retrieving the required ID before proceeding. Next comes the critical pre-flight validation phase. The agent hits an audience estimate endpoint to verify the demographic meets minimum size thresholds. Every single one of these conversions and mid-thought lookups is dictated purely by the pro system prompts written in the Markdown file. Delegating data sanitization and viability checks to the agent logic ensures that by the time the system reaches write endpoints, it delivers a schema-compliant payload. This raises a critical engineering question. Without compiled orchestration code, how does the LLM know exactly how to pass that clean data between the campaign, ad set, and ad endpoints? To understand how, look at this YAML document. It highlights an explicitly defined links array. Notice the line of code highlighted in the 201 response block. While humans read prose documentation to figure out relationships, the LLM reads these machine-readable links to map connections directly. The specification tells the model the exact runtime logic. It maps the ID output of one response directly into the required parameter of the next request. This lateral linking behavior maps the entire entity hierarchy, pulling the model forward through the complex workflow step by step. By utilizing OpenAPI links, the raw YAML documentation functions as the multi-step orchestration state machine. The need for Python or Node.js workflow code is entirely eliminated. Parsing an API graph perfectly means nothing if the final network execution is unsafe or opaque. Spotify engineering deliberately avoided building a compiled SDK to handle that final execution layer. Instead, the execution artifact the agent produces is a raw, unabstracted curl command. This presents a final hurdle: authentication. The system needs to append secure credentials to a raw string without exposing those tokens to the LLM. To solve this, the architecture relies on a pre-tool use hook. This hook acts as a silent interceptor. It catches the curl string right before execution and securely injects the necessary OAuth bearer tokens. This gives developers a distinct advantage. They gain the ability to view, copy, and debug the exact HTTP request generated by the model before it ever impacts an active advertising budget. Combining agentic reasoning with raw command line tools prioritizes complete execution transparency over the comfort of opaque abstractions. When you compare the legacy approach with this architecture, the visual contrast is stark. On the left is the traditional method, dense walls of orchestration scripts burdened with endless try-catch blocks. On the right is the replacement, clean prose paragraphs in a Markdown file operating alongside a single YAML specification. Building this system requires stripping away heavy enterprise frameworks in favor of native primitives like curl, jQuery, and standard Python 3. The engineering focus moves from writing strict logic gates in code to authoring precise prose and explicit schema links. The single source of truth for the entire application is the unmodified OpenAPI specification. This architecture provides a functional model for managing complex API integrations without constructing intermediate code layers. Natural language, grounded by explicitly linked and machine-readable documentation, provides a resilient interface for the Spotify Ads API.